Hey folks, Dr. Tom McNamara back again for our course in trigonometry. We are working on applications of right triangle trig. And this type of problem, it's a neat problem. It's an application to geometry. Let me go grab my chalk holder a sec. Where is it? It's over there. Okay. So we are tasked with finding the area of an equilateral triangle whose side length is 6 feet. Now I'm sure you remember that the area of a triangle is 1/2 the base times the height. Okay, now equilateral, well, that means equal sides. Okay, so the sides are all the same length. So this is our picture, maybe something like this. Now, if all the sides are the same, that means all the angles are the same as well. All the angles would have to have the same measure. Now we know that the angle sum in a triangle is 180 degrees, so each of these angles has to be 60 degrees. Now what I really need to find this area is the height. I take 1/2 the base times the height. So here's my base. There's my height. I don't know what that height is. And of course, the height has to be measured perpendicular to the base. It's the distance from the base to the apex of that triangle measured perpendicular. Okay, so now, if this is 6 feet, and I'm going from the base to the apex there, I'd have to cut this angle in half, right? So I'd have a 30-degree angle there. Going from here to here, that's 6 feet, that must mean this is 3 feet. This is 6 feet. There's a couple of ways we can do this. I'm interested in this height right here, so I can use my trigonometry. Okay, I got the hypotenuse. I want the, let's say, the opposite side. So I can do sine of 60 equals h over 6. So if this equation is true, then that means h equals sine 60 degrees times 6. So works out to be 3 radical 3, I believe. If you look back to our video on right triangle trig for some special angles, we actually made a little table. And I think sine of 60 degrees was radical 3 over 2. And we got that from a 30, 60, 90 triangle. So sine 60, we know the exact value. It's radical 3 over 2. There's a factor of 2 in the 6 that cancels with the factor of 2 in the denominator of radical 3 over 2, leaving us with 3 radical 3. Another way to compute this is to remember your special triangles. Okay, 1, 2, radical 3 going next to the 30. So you scaled that up to a 3. That means this would get scaled up to a 6. That means this would be 3 radical 3. Okay, so that is my height. So over here, 1/2 the base, which is 6, times the height. We just computed it's 3 radical 3. So 9 radical 3 square feet for the area of this triangle. Okay, so a neat little application of trigonometry to a geometry problem.